The next physical quantity we are going to treat now is conductance. Under what? Conductance. And the symbol is what? Is G. You know we have resistance. If resistance, and we have conductance. This one is opposed to flowing of current. This one is what is ability of current to what to flow. So they are reciprocates. So what is conductance? Conductance, this is the ability of a material to allow the flow of current through through it. The ability of material to oppose the flow of current is called resistance. To allow the flowing of current is called what? Conductance. And it's known as what? As G. This conductance is the reciprocal of resistance. That is the inverse of what? Of resistance. It is measured in Siemens. It is measured in what? Siemens X or per ohm. That's the unit for what? Conductance. So mathematically, conductance is G over 1 over what? R. Reciprocal of resistance is conductance. Ability to conduct current is conductance. Ability to stop or oppose flowing of current is called resistance. They are what? They are inverse. Yes, let's solve question on this one. Question 1. If the resistance of a metallic conductor is 15 ohms, what will be its conductance? Solution. You are given what? Resistance as what? As 5 ohms. Resistance is 15 what? Ohms. Conductance is unknown. Using conductance, G is 1 over resistance. 1 over resistance is 1 over what? 15. So press 1 over 15. 1 over 5. Press 1 over 5. It will give us what? 0.2 per watt per ohms. Therefore, conductance is what? 0.2 per watt per ohms. That is what? Conductance. The next thing is what? It's like we have factors that affecting what? Resistance. And then we also have factors that affect conductance. So yeah, factor that affect conductance is almost similar to what? The factor that affects what? Conductance or resistance. Number 1, we have length. As we all know, that is what? Length here. The conductance is inversely proportional to the length. If you remember, the resistance is proportional to the length. When the length is increased, the conductance will reduce. When the lead is what is reduced, conductance will what will increase. That's it. And the next one we have what cross-sectional area. For cross-sectional area, conductance is proportional to area. So when the area is increases, the conductance is also increases. But when the area is decreases, conductance is also what decreases. The next one is conductivity. Conductivity of the material. Which is conductor. This is what? The symbol. And the last one is temperature. I've explained this rate of temperature in resistance. When temperature is increased for conductor, the resistance will what will decrease. The resistance will increase. So the resistance increase, the conductance will what decrease. Semiconductor temperature increase, resistance decrease, conductance increase. That is what temperature. And we can now say what the conductance, the what conductance of a material can be expressed in terms of the first three factors above. Factors above as shown below. You cannot say what? From resistance, we have this formula. The next thing is what? Reciprocate the both sides. Reciprocate the both sides. By doing that, you put 1 here. 1 over R will be equal to the what? 1 over resistivity over A. This will later give you what? 1 over R. We have A over resistivity R. Yes, since, can I say what? Since 1 over R is what conductance. Put it here. Conductance G equal to the what? A resistance R. This is the formula for conductance. And the last thing is, we have resistance and resistivity. So conductance and conductivity. Let me explain the conductivity. Conductivity. Conductivity symbol is sigma. Is sigma. So this is the conductivity. What is conductivity? This is a measure of the ability of a material to conduct electricity. To conduct electricity. Full stop. And it is the reciprocal of resistivity. It is the reciprocal of resistivity. Resistivity. Conductivity. Yes, it is measured into what per ohm, and the formula for resistivity is, let me say what, it is measure, the measure means what, resi, what am I calling you? This is measure in per what, per ohm, and mathematically conductivity, conductivity symbol is 1 over resistivity. So you can now have what? Yes. Therefore, the sigma equal to the what? 1 over resistivity. You can call this one what? If I call this equation what? 1. So this will be what? Equation 2. And this will be what? Equation 3. Substitute this equation 3 here. You can have what? So if you put this 1 over this to this side, you will have G should be equal to the what? The conductivity A over what? Resistivity R. This is what? Equation 1 over 4. Good. Let's solve with just one question, then I will stop for today. In my next class, I will continue from the arrangement of resistors, and from there we move to the Kirchhoff's law of DC circuits. Let's solve this question. Question 1. Determine the conductivity and conductance of a 4-meter long wire. Long what? Wire whose cross-sectional area is 0.5 m squared, given that its resistivity is 0.01 ohms. This question is very simple. So, solution. We are given length of wire L. We are given cross-sectional area. We have to find conductivity and conductance. Okay, number figure 1. What is conductivity? T, which is sigma, is 1 over what? Resistivity. What is resistivity given here? 0.01 is 1 over 0.01 for the resistivity given. If you press your calculator, you're supposed to have what? 100. 100 per ohm per meter. That is the unit for conductivity per ohm per meter. Correct it? So the next thing is what? Roman figure 2. We are asked to find the what? Conductance. Conductance formula, conductance is what? Is G. And the G formula is what? The conductivity A over what? Where did I see this one again? Conductivity A over L. Good. So what is the conductivity? I got what? 100 multiplied by area given is 0.5. 100 times 0.5 divided by what? Length 4. 0.5 times 100 is 50. So G will give you what? 50 over what? 4. 4 divided by what? 50. 50 is 25 divided by 2. We have 12.5 per ohms. So that is all about what? Conductance and conductivity. Good day.